Hello students, now we will be studying about elements of Earth magnetic field. What are the elements of Earth magnetic field? They are the elements which help us to find out the exact magnetic field at any point. If you know these three elements, there are three elements. If you know these three elements or the value of these three elements, then you can find the magnetic field of Earth at any given point. Even here you can find the magnetic field. Even if you go for another place, you can find each and everywhere the exact magnetic field of that particular point. And you all must be knowing that magnetic field on Earth keeps on varying. It is not fixed at any point. If here it is something, it will be varying at some other place. It varies from place to place. Okay, there may be, like example, there may be cores inside the Earth where there are mining ores may be there. So at that point what happens? Some amount of magnetic field get deflected. Okay, so magnetic needle also gets deflected. So at that particular point the magnetic field may change. So if you know these three elements, you can find out that what is the exact magnetic field at that particular point. Now we'll be talking about what are the three elements. The three elements, first one is angle of declination, second is angle of dip, and third one is horizontal component of Earth's magnetic field. So first of all we'll start with the first one, that is angle of declination. What is angle of declination? The angle of declination is the angle between the geographical meridian and magnetic meridian. Now before moving ahead, you need to know what is meridian. Angle of declination is angle between geographical and magnetical meridian. But what is meridian? Meridian is nothing but a plane which consists the axis of that point. Like for geographical meridian, it contains geographical axis and the point which it wants to, or the point at which you want to know the magnetic field. Suppose at this point you want to find the magnetic field. You know what is the geographical meridian? Geographical meridian has straight axis. This is Earth and this is the geographical axis, North Pole and South Pole. So if you want to find geographical meridian at this point, then you need to have a plane like this, which contains the axis as well as the point that is required. Now if you want magnetic meridian, what is the magnetic meridian? Magnetic meridian, you know that the magnetic axis is slightly inclined. Magnetic meridian has the magnetic axis is slightly inclined. So magnetic meridian will be of this form. This will be magnetic meridian, which means that the angle between the two planes, one is this inclined plane and one that was straight plane. The angle between that two plane is your angle of declination. Angle or declination. If you want to understand in a very simple manner, then simply you can know that if this is a magnetic needle, this angle will be your angle of declination. This is angle with geographical meridian, or you can say North Pole, South Pole. This will be magnetic North Pole and this will be magnetic South Pole. Geographical. So this angle will be known as your angle of declination. Angle of declination. Here it should be actually not North Pole. Here it should be the magnetic needle. If the magnetic needle shows, generally what happens, magnetic needles points in the magnetic north and magnetic south pole of that position. So the angle between the magnetic needle and geographical meridian or geographical axis is known as angle of declination. Okay. So now we'll move ahead with next topic, that is angle of dip. Angle made by Earth's total magnetic field with horizontal component in direction of magnetic meridian is called angle of dip. So here let us understand this. We'll look at the definition later. Suppose you are using a magnetic field that is moving in this manner, in horizontal manner. But if you allow it to move freely in vertical also, this is horizontal. जब भी कंपास लेके जाते हैं, मोबाइल में भी देखते हैं, तो कैसे देखते हैं? We just put the thing like this. कंपास को ऐसे रखते हैं, तो मैग्नेटिक नीडल सिर्फ horizontal direction में मूव कर सकते हैं. It can't move in vertical direction. So if you allow this magnetic needle to move in vertical direction also, okay, और अगर कहीं पे जाके रख दिया, if you go and keep this magnetic needle at some point and allow it to rotate freely in vertical direction, then the angle made by the horizontal surface, or you can say horizontal component of magnetic field and the magnetic needle, okay, this manner. This is horizontal surface, or you can say horizontal component of magnetic field and the angle made by the needle, magnetic needle, with this will be your angle of dip. Okay, suppose here you can see the magnetic needle which is free to rotate in vertical plane, Okay, now needle aligns with the magnetic field, Earth's magnetic field. Okay, यहाँ पे क्या होगा? It will be in north south direction. Here also it will be in north south direction. Okay, so if you want to find what is the angle of dip at particular point, suppose we have two common consideration, that is one is over here and one is over here. यहाँ पे क्या होगा? सरफेस के साथ कौन सा एंगल बनेगा? At this point, south and north. At the poles, what is the angle of dip? Angle of dip will be 90 degree. Angle of dip is denoted by I. Here it will be 90 degree at poles. Now if we take it at equator, this is a part of our equator. So if we take at equator, what is the angle? Equator पे ऐसी surface होगी, वहां पे ऐसे it will be lining S and N. So यहाँ पे क्या angle बना है? It is parallel to it. So the angle will be 0. At equator I equals to 0. Means the angle which it is making, or the angle which magnetic needle is making with the surface is known as the angle of dip. So now suppose if you take at any point, suppose you take it at here, at this point. Okay, if you want to find the magnetic field or the magnetic component, if you keep the magnetic needle at this place, it will be somewhat tilted. Okay, suppose it is in this position, south pole and north pole. This is the magnetic needle which is showing over here. With this we will be studying about the third component, that is horizontal component of magnetic field. For any force, like if we had any force, what we need to find the component? We just made a perpendicular, one in horizontal direction, one in vertical direction. So suppose that magnetic needle shows the total magnetic field, gives a total magnetic field of that place, then we can make two components, one is vertical and one is horizontal. So the horizontal will be named as BH and the vertical will be known as vertical to the surface, vertical component of magnetic field. So here we can understand that what is angle of dip, what we have already studied. That angle of dip is the angle which is made by magnetic needle to the horizontal surface. So here you can see that this is the magnetic needle and this is the horizontal to the surface, and that is horizontal component. So the angle between them is your angle of dip. Here you can also say that this is generally parallel to the surface of Earth. Okay. So now if you want to draw all three things in a single image, single image, then what we shall do? First of all, we will make two meridians. One is magnetic meridian and one is geographical meridian. Suppose at this point we want to find out. So from here I will draw this is a geographic meridian. If I want to find a magnetic meridian, this will be my magnetic meridian, or I can draw it in lower portion also. I will draw it in lower portion so that I can make the angles properly. This is geographic meridian. This is magnetic meridian. The angle between the two, geographic. Let me say this is geographical meridian. North pole, south pole. Okay, you can do it. So this is geographical meridian. This is magnetic meridian. Okay, the angle between them is angle of declination. So this will be your D, that will be angle of declination. Now suppose if you keep a magnetic needle at this point, the magnetic needle will be drawn in this direction, it will show this direction. Okay, this will be your magnetic needle. So what becomes a horizontal and vertical component? This upper line, this line becomes the horizontal component and this line becomes the vertical component. So this will be your BH, this will be your BV. So the angle between the magnetic needle and the horizontal component, that is this angle between horizontal component and the magnetic needle is your angle of dip. So this will be I. So in here you can see all three things: geographic meridian, magnetic meridian, angle between them is D, that is angle of declination. Now in magnetic meridian you have one is horizontal component and one is vertical component. If you put a magnetic needle at that particular point, it will show some direction. Then the angle between the horizontal component and the magnetic needle is known as your angle of dip, that is I. And the other one, the horizontal component, you already know it. And from this figure, one thing was left, that was to know what is the value of BH, or that is horizontal component. What is the value? If this is I, this is magnetic needle, then this will be your BH is equals to BE cos I, where cos I is your angle of dip and B is your effective magnetic field. So if you know the value of horizontal component and angle of dip, you can find the value of magnetic field also. Similarly, if it is vertical, then BV is equals to BE sin I, which means that tan I is equals to BV upon BH. BV upon BH. BV is vertical component of that particular point and BH is horizontal component of magnetic field at that particular point. I hope these things are very clear to you. In a very short manner, I will very fast explain you once again. Angle of inclination is the angle between two meridians, magnetic and geographical. Okay, that is angle of dip. What is angle of dip? Angle of dip is between the two components of magnetic field only. One is the effective magnetic field and one is with the horizontal component of that magnetic field. Okay, so this will be I, that will be angle of dip, and this horizontal itself is a horizontal component of magnetic field. And here in the same figure we have drawn three things. Okay, I hope this is very clear to you. Thank you students, keep studying, have a safe day, have a nice day.